Welcome to Mission Control, everyone. I'm your flight director for today's explainer, and we are initiating the pre-launch telemetry for one of the most notoriously volatile systems in the Cambridge AS and A-level accounting 9706 syllabus. We are talking about standard costing, specifically mastering direct labor rate and efficiency variances. Now, I want you to treat this exam paper like a multi-million-dollar flight system. It requires absolutely perfect execution. Before we even leave the launch pad, let's look at our central console screen. The objective is a multi-part past paper question, and I want to introduce you to two theoretical candidates, our two pilots in the simulation, Pilot Alex and Pilot Sam. Pilot Alex is the kind of candidate who overcomplicates every single data calculation, burning way too much exam time, which is essentially our fuel, on the wrong metrics. Meanwhile, Pilot Sam has the opposite problem. Sam completely ignores the structural boundary constraints of the syllabus, risking a total systemic breakdown when writing extended answers. The difference between an average grade and a top-tier A-star often hinges entirely on avoiding these pilot errors. Today, we're going to calibrate your systems so you can execute perfectly.
Okay, let's really dive into this mindset shift, because this is where the flight path diverges. There is a fundamental difference in how candidates approach their flight training. Pilot Alex represents that grade B mindset. This is pure brute force memorization. You learn the variance formulas by rote, you just plug in the numbers, and you pray to the exam gods that the question looks exactly like your textbook. But, when turbulence hits, when the question introduces a slightly new variable, the whole system crashes. The grade A-star mindset, on the other hand, is what we are building today. Top-performing candidates exhibit a fully connected conceptual understanding. They don't just memorize the formula. They understand the underlying physics of why that formula works. Because they know the why, they can easily transfer that knowledge and apply it to completely unfamiliar, highly complex contexts without missing a beat. They treat the exam like a dynamic simulation, not a static memory test. To get you operating at that elite level, we're going to follow a strictly structured flight plan today. Number 1, core principles. Number 2, technical methodology. And number 3, critical analysis and evaluation. Let's fire up the main engines. Initiating Phase 1, core principles. Cambridge examiners expect you to demonstrate an absolute, unshakable mastery of the fundamental theoretical architecture before you even think about touching a calculator. Think of direct labor rate and efficiency variances as the critical system parameters you must constantly monitor to clear orbit. We aren't just doing math here, we are diagnosing a living, breathing business model. This theoretical framework is built on incredibly precise definitions, causal relationships, and systematic evidence-based reasoning. Let's look at Pilot Alex again. Alex will calculate an adverse efficiency variance and just stop there, burning up on reentry. But you need to ask the diagnostic questions. Why did the labor rate change? What specifically caused the efficiency to drop? Was there a machine breakdown? Did they hire unskilled workers to save on the rate variance, which directly ruined the efficiency variance? You have to understand these causal links. In fact, the principal examiner reports explicitly state the candidates who reference cross-topic connections, showing how these variances impact other areas of the business, achieve significantly higher marks. It proves you understand the entire mechanism, not just a single isolated gear. To really visualize this, imagine a high-tech UI console overlay right in front of you. To clear the atmosphere, you have to successfully navigate 3 distinct cognitive domains simultaneously. First up is knowledge and understanding. These are your basic readouts and definitions. Second is analysis. This is where you actually calculate the variances and interpret the mathematical relationships. And third, the highest altitude, is evaluation, your ability to judge the data, compare outcomes, and recommend a course of action. Listen, if you want those elite marks, you literally cannot rely on just one thruster. You must demonstrate competence across all 3 of these domains simultaneously in your extended responses. Before we lock in our calculations, I want to give you a memory hack straight from the mission briefing to help you encode these concepts. Standard costing can feel incredibly dry and abstract. So instead of just staring at standard hours versus actual hours, use a visual story method. Run a mental simulation. Picture a real, loud factory floor. Visualize the workers clocking in, imagine the machinery humming, picture the wage slips changing hands, and literally visualize a manager holding a stopwatch. When you tie these abstract floating numbers to a grounded visual narrative, it locks those causal relationships deeply into your memory for exam day. Transitioning now into Phase 2, technical methodology. The theory is our foundation, but technical execution is how we actually secure our method marks and keep the ship flying. All right, I am pausing the simulation for a critical alert. Before we fire the secondary boosters to secure maximum method marks and optimize this flight path, I need you to do something. Subscribe to Ace the Exams right now at Ace the Exams and turn on all your notifications so you never miss a mission-critical update. Okay, resuming simulation. When you are faced with a complex past paper question, you need a standardized 5-step processing sequence. Do not just blindly start calculating. That's what Pilot Alex does, and it burns precious exam time. Step 1. Deconstruct the exact command keywords. Are they asking you to state, calculate, or evaluate? Treat these as your system parameters. Step 2. Extract only the relevant data from the noisy text and tables. Step 3. Select the correct analytical framework. Step 4. Execute your calculations with absolute crystal clear notation. And finally, Step 5. Verify your numbers and present them. This strict processing sequence is your shield against making silly, catastrophic errors.
Now, let's say our crew encounters a massive roadblock mid-paragraph during an extended response. Pilot Sam is writing an analysis, but the evidence links are failing. The structural integrity is breaking down. This is where I, as the flight director, have to override the console and inject a structural template to save the trajectory. We call it the PEEL framework: point, evidence, explanation, and link. The syllabus demands strict professional skills. You must apply the correct formats and terminology. So, when evaluating performance, you make your point. You back it up with evidence, your specific calculated variance. You provide an explanation for why it happened. And finally, you link it back to the overarching management decision. Your data interpretation must naturally draw logical, evidence-based conclusions. You are writing as an accounting professional advising a board of directors, not a student guessing on a quiz. Engaging Phase 3. Critical analysis and evaluation. We are entering the highest altitude of the syllabus, now focusing on higher order objectives and exactly what principal examiners are actively warning against. Time for an interactive viewer radar challenge. I want you to imagine a highly complex data table on your screen right now, and a 60-second visual countdown clock ticking away. Your mission is to locate the hidden core variable to evaluate the business's performance. To do this before the clock hits 0, you must master the deconstruct, solve, evaluate loop. You identify the given information, break it down logically, and solve it systematically. But the real A-star marks? They are won in steps 4 and 5. Checking for reasonableness, asking yourself, does $1 million adverse variance actually make sense for a tiny local bakery? Probably not. You must make justified recommendations based strictly on the data you just processed. Let's run a second simulation right here. I call this one debris detection. I'm going to scan a sample student answer, and you need to spot the critical failure. Here's the sentence. The labor efficiency variance is adverse, so the factory's performance is bad and they should fire the workers. Debris detected. Warning. That sentence will completely tank your evaluation score. Top evaluation marks are only awarded when you critically evaluate the evidence by identifying the limitations of standard costing, the underlying assumptions being made, and alternative interpretations. Maybe the efficiency variance was adverse because purchasing bought cheap, low-quality materials that kept breaking in the machines. You have to look at how these external factors affect the final conclusions. If you just give a blanket adverse equals bad statement, you're leaving massive, easy marks floating out in space. As we prepare for our final approach and touchdown, we need to navigate around the most common wreckage left by past candidates. These are the top 3 direct warnings straight from the principal examiner reports. Number 1, answers are way too vague. Costs went up. That is a fail. Examiners want specific, laser-focused details. Number 2, forgetting to check format and presentation. Doing sloppy math in the margins loses you professional method marks. And number 3, this is the big one. Answers that are not specific to the given context. If the exam scenario is about a specialized furniture manufacturer, your efficiency analysis better be talking about wood quality, carpenter labor hours, and machinery breakdowns, not generic, boilerplate business terms. Generic answers will instantly kill your A-star trajectory. I am broadcasting a massive system-wide examiner alert right now. Listen to this direct quote. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This right here is the ultimate exam pitfall. It is the equivalent of pulling the eject lever by accident. If you mix up your rate variance terminology with your efficiency variance terminology, your entire extended response structurally collapses. Before you start spinning a narrative in your essay, define your terms clearly right out of the gate. Establish your baseline. Touchdown confirmed. Pilot Alex and Pilot Sam, if they apply these frameworks, just secured a full mark landing sequence. So, I leave you with this final pre-flight question scan checklist. How will you adapt your study strategy and apply this deconstruct, solve, evaluate loop to your very next past paper? Knowledge without actual simulated application won't move the needle at all.
I am challenging you to sit down with a past paper today and execute this exact flight path. And remember, to keep optimizing your exam systems, hit that subscribe button for Ace the Exams at Ace the Exams, enable the notification bell so you never miss a briefing, and drop a comment below sharing your exact subject and tiers so we can prep our next simulation. Outstanding work today, team. See you on the next mission.